Hey guys, welcome back everybody. Hope you all are doing great. Today in this video we are going to discuss all about NAT on Cisco ASA Firewall. We are going to discuss everything about network address translation on ASA Firewall. Okay, like different kind of NAT, static NAT, static PAT, dynamic NAT, dynamic PAT. Then we are going to learn different section of NAT like section 1, section 2, section 3. What is the order of these sections? Means as ASA is going to look up section 1 or section 2 or section 3 first, right? So what is the order of section? Then we are going to discuss the order of NAT, like how NAT look up in ASA. So suppose you have multiple rules, right, for the translation. So ASA is going to check which rule first, right? So what is the order of preference for NAT on Cisco ASA Firewall? Then we will discuss the implementation, guys, like how we can implement this kind of NAT on Cisco ASA. Again, we have multiple options to implement network address translation on ASA Firewall. So we'll see everything in this single video. So guys, this video can be lengthy, but this video is going to be very useful, very helpful for all network engineers. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. Okay, now guys, without wasting our time, let's begin. You know, ASA Firewall supports all types of NAT. It supports static NAT, static PAT, dynamic NAT, dynamic PAT. Even it also supports twice NAT. Okay, so don't worry, we'll discuss everything. Okay, so first of all, try to understand the difference between static and dynamic NAT, guys, right? So if I will talk about the dynamic NAT first, so let me write here dynamic NAT is many is translation of many private IP addresses into a range of public IP addresses. What I am saying, dynamic NAT is a translation of many private IP addresses into a range of public IP addresses. Means, let's say in your network there is one segment, let's say 192.168.1.0/24. Design is like this. Let me will implement NAT in this scenario, in this topology, but for now just assume you have a network like this. There is one switch and then lots of end devices are there. This switch is connected with one ASA firewall, and this ASA firewall is connected with internet. So you want to provide internet access to these all end users, right? How you will configure the NAT? Here you can configure the dynamic NAT, right? Because dynamic NAT is many to a range of public IP address. Many private IP address can be translated into a range of public IP addresses. So let's say here I am using subnet 192.168.1.0/24, and here I am using subnet 1.1.1.0/29. Let's say .1 is running over here, and .6 means last IP address of this subnet is running on internet router, right? So you have still some IP addresses, guys, over here, public IP addresses like .2, .3, .4 and .5. Okay, so you can create a pool of these public IP addresses to translate these private IP addresses, right? This entire subnet. So under this subnet we have lots of private IP addresses, right? First private IP address is going to be 192.168.1.1, and last IP address is going to be 192.168.1.254. So 254 IP addresses are there, and these 254 IP addresses can be translated into this public range. Okay, so this is what dynamic NAT. But guys, there is some limitation of dynamic NAT. We are going to discuss it, don't worry. Hope for now dynamic NAT is clear to you. Okay, so see, the limitation. What is the limitation of dynamic NAT? So in my pool, guys, how many public IP addresses are there? 4 public IP addresses are there. That means only 4 users can access internet at a time. Why? Because in the pool you have 4 IP addresses: 1.1.1.2, 1.1.1.3, 1.4 and 1.5. Let's say PC1, whose IP address is .1, 192.168.1.1, is trying to access internet. So ASA is going to translate source, right? Means ASA is going to translate 192.168.1.1 into 1.2 to this public IP address, right? Now this public IP address is in use. In the same way, when second PC will try to access internet, it is going to translate private IP address of PC2 into one public IP address, let's say .3. In the same way, for next PC it is going to use .4, and for next it is going to use .5. So now 4 devices are using internet, right? What will happen if fifth PC will try to access internet? It will forward request to ASA Firewall, right? And guys, NAT is running, so ASA need to translate private IP address into public IP address, but ASA don't have any free public IP address. So this packet get dropped. ASA is going to drop this packet as there is no free public IP address available in the pool. So this is one limitation of dynamic NAT. Another limitation can be, it is unidirectional. Means you can access the internet, but internet cannot access you. Getting my point? You can access the internet, but internet cannot access you, right? So if someone will ask you what is dynamic NAT, and guys, this is interview question. Sometimes interviewer is also asking questions from NATing, like they can ask you if tell me in which scenario ASA is going to translate source or ASA is going to translate destination. So whenever my end user will try to access internet, right, it will forward request to ASA Firewall, and ASA Firewall is going to translate source. When reply will come, it will translate the destination, right? And in dynamic NAT, only IP address get translated, right? So this is IP to IP translation. Port number not get translated here. Okay, so hope this is dynamic NAT is clear. So dynamic NAT is many to a range of public IP address, or you can say many private IP addresses are hidden behind a range of public IP addresses. Okay, so if range is full, then remaining traffic get drop. This is very important point. Let me write here. If range is full, then remaining traffic get dropped by ASA Firewall. Done. Next thing about ASA Firewall is it is IP to IP translation. It is IP to IP translation, means port number not get translated, right? Port number not translated in dynamic NAT. And in the range, guys, there should be minimum 2 public IP address. Minimum 2 public IP address is required to configure dynamic NAT or to implement dynamic NAT. Okay, so that's why generally we are not using dynamic NAT in real time in the production network, because you can see dynamic NAT is really not very convenient, because I am not going to buy hundreds of public IP addresses or thousands of public IP addresses for 100 number of PCs or end devices, or for 1,000 number of PCs or end devices. This is, guys, lab in EVNG, right, in the simulation. But just think about the real-time network, about the production network, where you have 100 number of subnets, 100 number of branches, 1,000 number of branches, right? So in the real time, in the production network, generally we are not using dynamic NAT nowadays. Okay, that's why dynamic PAT comes in picture, where multiple or many private IP addresses are hidden behind a single public IP address. Okay, what I'm saying, many private IP addresses are hidden behind a single public IP address. In dynamic PAT, source IP as well as source port get translated. Source IP address translated to a single public IP address, and source port get translated into a unique port number, right? So we are not using dynamic NAT, you can say. Then guys, next thing is, where is the presentation here? So it is IP to IP translation, and one more thing here, it is unidirectional. It is unidirectional, means you can access the internet but internet cannot access you. Then why we come up with dynamic PAT? Next thing is dynamic PAT. So hope reason behind dynamic PAT is clear, right? Why we come up with dynamic PAT? Because dynamic NAT is not convenient. Fine. So, and if someone will ask you what is dynamic PAT, so dynamic PAT is many to one translation, many to one translation, you can say, right? Means many private IP addresses can be translated into a single public IP address. And in dynamic PAT, source IP as well as source port get translated. Source IP will be translated to a public IP address, a single public IP address, and source port will be translated to a unique port number. And this is also unidirectional. Dynamic PAT is also unidirectional. It is also unidirectional, means you can access the internet but internet cannot access you. Okay, so in dynamic PAT guys, what you can say, for let's say DMZ or for server, what we need, let's say in my scenario, see there is one server, or let's say there is one DMZ John, right, where we have lots of servers. So what I want to provide access to my internal server to outside user. Let's say on the internet there are lots of user, right? So what I want, that outside user should be able to access my internet. So if I want to configure NAT on ASA firewall in such a way so that internet can also access me, which is not possible in dynamic NAT or in dynamic PAT. So that's why we come up with a static NAT. Okay, in dynamic NAT and dynamic PAT, internet cannot access you. Both are unidirectional. So that's why we come up with a static NAT, so that internet can also access me. And guys, whenever you have servers in your internal network, you will configure a static NAT, right? So next is a static NAT. Hope dynamic NAT and dynamic PAT is clear. Okay, so for DMZ or for the servers, we come up with a static NAT, right? And guys, a static NAT is one-to-one translation. One-to-one translation means one private IP, one private IP address is hidden behind one public IP address. Done. So it is one-to-one translation. One private IP address will get translated into one public IP address, and vice versa. When your server will send request to internet, source will get translated, when internet will access internal server, destination will get translated. Okay, so here source and destination both get translated. Source and destination both get translated. In dynamic NAT or dynamic PAT, only source get translated, right? Destination never get translated. But in the static, means in the static NAT, source and destination both get translated. Static NAT. Done. So when traffic is going from inside to outside, source get translated, and when traffic going from outside to inside, destination get translated. That's why static NAT is bidirectional. You can access the internet and internet can access you. Definitely you need to configure ACL to allow lower security level to higher security level traffic, because see, if internet is going to access the internal server, this server, right, here security level is 0, here security level is 100. So by default, lower security level to higher security level traffics are not allowed. So you have to configure the ACL to allow lower security level to higher security level. But that is secondary thing. That is not concept of NAT. With the help of static NAT, we can access the internet and internet can access you. Fine. The next is static PAT. Static PAT. So static PAT, why we come up with a static PAT? Guys, it is also unidirectional, right? Static NAT is bidirectional. Let me write here. It is bidirectional, right? So only a static NAT is bidirectional. Dynamic NAT, dynamic PAT, or static NAT, these all are unidirectional. Static NAT, it is also unidirectional. It is unidirectional. Done. So what you can say is that static PAT is unidirectional. Source and destination get translated. Here also your source and destination both get translated. When outside user will send traffic to inside, destination get translated. When inside user will send traffic to outside, destination get translated, right? So source and destination both get translated in the static PAT. Now question is where we use a static PAT, because dynamic NAT use is clear that whenever I want to give I want to configure the NAT for general user, for my employees, right? Like whenever entire subnet should be able to access internet, I can configure the dynamic NAT, right? Or if we have problem with public IP addresses, means I have less number of public IP addresses in the range, so I can configure the dynamic PAT. So the scenario where we are configuring dynamic NAT or dynamic PAT is whenever we are configuring NAT to provide internet access to our entire subnets. Getting my point? In that scenario, we use these types of NAT. A static NAT is for servers or for DMZ. Whenever we have DMZ or servers in my internal network and I want to provide access to my internal server to outside user, we need to configure a static NAT. Then where we use static PAT? So guys, it is for condition. Let me write here static PAT. It is use for condition. Condition like condition like, let's say this a user want to access that branch office, then do the translation for him, right? Let's say I have this topology, guys, and here is one more branch, right, somewhere. So what I want to configure NAT on ASA firewall for this PC. Let's say that this PC, whenever this PC want to access this branch office then perform the translation, do the translation for PC1. In that scenario, we will configure what? A static pat. We'll configure a static pat. Okay, so you can say if you want to put the condition, you can configure a static pat. Now these are types of NAT, or you can say these are method of NAT. But what is the implementation? How we are going to implement NAT? So guys, let me remove this all and let me talk about the implementation. So if I will talk about the implementation, guys, understand very carefully because this is very, very important. Static NAT, dynamic NAT, static paired, dynamic paired, these are method of NAT or types of NAT. Implementation can be done by using two-way. Implementation can be done by using two-way. If you want to implement any type of NAT, any kind of NAT, static, dynamic, PAT, NAT, there are only two ways to implement this. Only two ways to implement this. Number one, first one is manual NAT. Manual NAT. Manual NAT means manual configuration, and it is a NAT configuration globally. Whenever we configure NAT globally, that is manual NAT, right? And guys, the second type of implementation is object based NAT, or we are saying auto NAT also. Auto NAT. What is the difference? Manual NAT means configuring NAT globally. Object based NAT means configuring NAT under the object, right? So always keep in mind this point. If you want to implement any type of NAT, you have only two ways to implement it. Either you are implementing a static NAT, dynamic NAT, a static paired, dynamic paired, doesn't matter. You have two ways to implement it: manual NAT and object based NAT. These two are implementation of NAT on Cisco ASA Firewall. Okay, and manual NAT means configuring NAT globally, not doing it under the object, and object based NAT means configuring the NAT under the object. Configuring NAT under the object, that is called auto NAT. Okay, so if you are configuring the NAT under object, that is called object based NAT or auto NAT. If you are configuring the NAT globally, that is manual NAT. Both supports all types of NAT. Both manual as well as object based NAT support static NAT, dynamic NAT, static paired, dynamic paired. Both supports all types of NATs, no problem. So dynamic or static, these are only method or types of NAT. Implementation can be done with manual or auto only. Hope it is clear. The next important thing is preference. How NAT is going to look up preference. Very important. Sorry. Now preference. How ASA preferred NAT, or how ASA check NATs. Right, let's say you have multiple rules or multiple section on NATs. You are matching multiple subnets. Let's say you are matching subnet 192.168.10.0, 10.10.0.0.0/8, let's say 20.0.0.0/8, let's say. You are matching these all subnets, right? You have multiple statements, NAT statements. So how ASA is going to look up for these statements, guys? That is what preference, right? So what is the order of NAT, you can say, or what is the preference of order of NAT, right? So always keep in mind one thing. ASA divide NAT rules in 3 sections. NAT divide NAT rules in 3 sections. ASA divides NAT rules into 3 sections. Section number 1 is, first one is section 1, then section 2, after that section 3. Why we divide NAT rules into 3 sections, guys, or why ASA divide NAT rule into 3 sections? For the preference, right? Means ASA is going to check section 1 first, then it will check section 2 first, then it will check section 3 first. Section 1 wins over section 2, section 2 wins over section 3, right? So this is how ASA check NAT's rule. First it will check section 1, then section 2, then section 3. Okay, the next thing, suppose we have same rule in section 1 and section 2 which matches, let's say, one subnet. Let's say on this ASA have section 1, this is section 1 and this is section 2, and both sections are matching same subnet 192.168.1.0/24, 192.168.1.0/24. Both section is matching same subnet, but ASA is going to check section 1 first, then it will check section 2, then it will check section 3, right? So which rule is going to match over here? Let's say we have 2 sections and in the both sections we are matching the same subnet. So then which rule is going to match? We have same rule under section 1 also and section 2 also. So section 1 wins over section 2. This is interview question. So 2 sections are there on ASA firewall and same rules are there in both sections. Then ASA is going to match which rule? The rule which is present in section 1, because ASA will check section 1 first, then section 2. So this is order of preference of section in NAT by ASA firewall. Okay. Recently one of my paid student received this question in interview, guys. That's why I told you this is an interview question. So interview ask him which rule is going to match. So rule in section 1 is going to match. Always keep in mind section 1 wins over section 2. You know, in all ASA, static NAT preferred over dynamic NAT always. Static NAT was always preferred over dynamic NAT. In old AS, you cannot change the order, but not in the new ASA. In the new ASA, guys, even you configure a static NAT later, ASA will giving preference to a static NAT, right? So here the order of NAT is based on section in the new ASA. In the new ASA, order is based on section. First of all, it will check section 1. In section 1, it will go top to down. Let's say in section 1, we have multiple rules. I'm matching this subnet 10.1.1.0/24. I'm matching 10.1.2.0/24. Then I'm matching 10.1.3.0/24. So these are rule number 1, rule number 2, rule number 3. So first it will look up for section 1, and under section 1 it will go top to down, right? Means it will check rule number 1 first, then rule number 2, then rule number 3. So if traffic is matching over here, rule number 1, it is not going to check rule number 2 or rule number 3. So that's why it's very important to configure the rule carefully on ASA firewall, because just suppose that in the rule number 1 you are denying a subnet, that is 10.1.0.0/16, right? Rule number 1. Rule number 2, 10. 1.1.0/24. Rule number 2 is permit, and this is deny statement in section 1. So ASA is going to, let's say ASA is receiving a traffic for 10.1.1.0/24 subnet for this subnet. So it is going to check section 1 first. In section 1 we have multiple rules. First it will check rule number 1 and see destination is matching over here, right? So it is going to deny it. It will never check rule number 2 or 3. So it is very important to configure rule correctly. Okay, so first of all it will check section 1. In section 1 it will go top to down. So rule number 1 given preference to rule number 2 and then rule number 3. Okay, so ASA will always check section 1 first, and within the section it will check top to down till the rule match. If no rule match in section 1, then it is going to check what? Section 2. If no rule match in section 2, then only it is going to check what? Section 3. And if there is no match in section 3, then ASA is not going to perform translation, right? ASA is not going to perform translation. So if someone will ask you what is the order of preference, NAT order of preference on ASA. So ASA always check section first 1. Under section 1 it will goes top to down. If there is no match, then it will check section 2. If there is match, then it will not check section 2, right? Again in section 2 it will go top to down. If there is no match, then it will check section 3. And again in section 3 it will check top to down. If there is no match in section 1, section 2 and section 3, then there will be no translation. So always section 1 is before our section 2 and section 2 is before our section 3. So we should think very carefully, right, about the NAT rule configuration. You should plan it, right, with your team carefully. Then guys, section 1. What is section 1? How to configure rule under section 1 and what rule will automatically goes under section 1. So guys, as I told you, there are two ways to implement all types of NAT: manual NAT and object-based NAT, that is auto NAT. So we can say manual NAT and auto NAT. And you know, auto NAT is nothing but section 1. Whenever, sorry, not auto NAT, manual NAT. Manual NAT is what? Section 1. So whenever we configure manual NAT, it automatically attaches to section 1, right? And manual NAT is what? Configuring NAT globally. So manual NAT is section 1. You can say manual NAT is section 1. Whenever we configure manual NAT, it automatically goes to section 1. Then section 2. What is section 2? Section 2 is auto NAT. Whenever we will configure auto NAT, it will automatically attach to section 2. Auto NAT is section 2. So if I configure auto NAT, it will automatically goes to section 2. Then what is section 3? Because we have only two ways to implement manual and auto. Manual is section 1, auto is section 2. Then what about section 3? So guys, section 3, it is also manual NAT. Section 3 is also manual NAT, but here you have to specify the keyword. Manually you can put manual NAT in section 3. You can say by default manual NAT is section 1. By default manual NAT is section 1. But if you want to put manual NAT in section 3, you can. You can put manual NAT in section 3 also. Okay. So section 3 is also manual NAT, and don't specify that this rule goes to a specific section, that is section 3, right? So you have to define it. Now I can plan manual NAT in section 3 by using some keyword. By default manual NAT is section 1. Now how to plan NAT rule and my NAT statement, how to plan it. For example, my entire LAN segment should be able to access internet. This is the general rule, right? My entire subnet should be able to access internet. This is a general rule. So I will always place this rule at the bottom, guys. I will always place this rule at the bottom. This is how you should plan NAT rule. Or you have some critical traffic like VPN rules, that should be on top in section 1, right? General rule should be at, at the bottom in section 3, and critical rules should be in the section 1 at the top, right? This is how we plan NAT rules for the production network. A specify rule, I will place them at the bottom in section 1, a specific rule, and general rule I will place it in section 3. And you know, in the real time, guys, or no, not real time, actually most of the people are still using, but I am not using AutoNAT. I don't like AutoNAT. I always configure manual NAT. I'm telling you the reason. Reason is what? Because in the AutoNAT you cannot arrange the rule, rearrange the rule, or adjust the rule. You cannot adjust the rule, right? So this is why I don't like, personally I don't like AutoNAT. I always configure manual NAT, but you want, you can configure, no problem. And I think AutoNAT is also not recommendation, guys, right? It is not recommendation, because AutoNAT I can't, or I can't adjust or rearrange my NAT rules. Whenever you will add a NAT rule by AutoNAT, by using this method AutoNAT, it will goes to bottom. It will goes to bottom in section 2, because AutoNAT is section 2. AutoNAT is section 2, right? And whenever you are adding the rule, it will goes to bottom only, and you cannot adjust it, you cannot rearrange it. So this is all about the implementation and preference, guys. Hope this is also clear. Now let's understand the configuration, right? How to configure it on Cisco ASA Firewall. So first of all, guys, I am going to configure Dynamic NAT. We are not using Dynamic NAT, so that's why let's finish it first. Dynamic NAT. And the method, the implementation method I am going to use over here is auto first. First we are going to use auto, then I will show you the manual configuration, manual NAT configuration. So if I am configuring Dynamic NAT and my implementation is through auto NAT, then it will, my NAT rules will goes in section 2. In section 2, because section 2 is the auto NAT. By default, section 1 is manual NAT, section 2 is auto NAT, and section 3 is also manual NAT, but with some extra keyword. Okay, now means we can place manual NAT in section 3 manually. We have to place, by default section 1 is, sorry, manual NAT is section 1. Now guys, on this ASA firewall, you can see so run NAT. So run NAT. We have one NAT configuration here. Let me remove it. So this configuration is under object. Under which object? Under object ABC. So I'm going to say object network ABC, and let me remove this entry, this NAT configuration. And now I'm going to say no object network ABC, and I think one more object is there, that is now. So run NAT. You can see we don't have any NAT configuration, guys. So run object, we don't have any object here, and object group, even we don't have any object group here. If you want to verify the ASA configuration, simply you can run command like so run so run interface G0/0. You can see G0/0 is my inside interface which is connected with core switch, and here security level is 100 and the IP address over here is 10.1.1.1, right? In the same way we can check 0/1 and 0/1 and 0/1 is my outside interface. Here security level is 0 and IP address is 1.1.1.1, right? And guys, on the internet router IP address is 1.1.1.6, means last IP address of this subnet. Ping 1.1.1.6. you can see I am able to ping the internet, right? That means here between ASA and internet I am using this subnet 1.1.1.0/29. first IP address is 1.1.1, second IP 1.1.2, third IP 1.1.3, fourth IP 1.1.4, then 1.1.5, and then 1.1.6. and I am already using this IP address on ISP router. This IP address on my ASA firewall, and we have these public IP addresses for pools. For pool, I can create pool with these public IP addresses. Okay, let me write here. Done. So on the ASA, I have verified the interfaces configuration, guys. Now so run OSPF, router OSPF. So you can see OSPF is running over here, and so route OSPF. I'm learning all my internal subnets through OSPF, right, from the core switch. So core switch is advertising these all prefixes to ASA firewall, and so route include 0.0.0. do we have default route? So yes, I have one default route, guys, towards ISP. Fine. So ASA configuration is correct. Here I have shown you the all configuration. Now I'm going to fix up the ICMP protocol as well. Fix up protocol ICMP, because by default only TCP and UDP traffics are allowed over here. Okay, now I am going to configure, let's say, NAT on this ASA so that my LAN user can access internet. Let's say this is my private subnet 10.1.1.0/30. 10.1.1.0/30 is my subnet. Or let's say this VLAN 10 is my subnet, guys, and I am going to configure NAT on ASA firewall so that these user can access internet. Let's say VLAN 10 is my data VLAN. My general employees are there, right, in this VLAN. So I want to provide internet access to these users. For that I am going to configure NAT on ASA firewall. Okay, so to configure the NAT on this ASA firewall, how many object is required, right? First of all, what method I am going to use? Auto. And which type of NAT I am going to configure? Dynamic NAT. Dynamic NAT by auto NAT. Okay, so let me access the ASA. So yes, how many object is required, guys? If I want to translate complete subnet, that is 10.10.1.0/24. here you can see the subnet VLAN 10 subnet 10.10.1.0/24. So I want to translate complete subnet, that is 10.10.1.0/24, to a range of public IP addresses, right? And range is, let's say, from here I'm going to use this range 1.1.1.2 to 1.1.1.3, right? And minimum 2 public IP addresses are required to configure dynamic NAT or dynamic PAT. Minimum 2 public IP addresses are required. So let's say this is my range. So you tell me how many object is required. Guys, I need 2 object. One one first who I have to NAT, that is my private subnet. I need to translate this subnet, means private IP addresses from this subnet. So I need one object for this network, guys, like who I want, I have to translate. And the second object is what should they translate to, right? So what will be the public IP address? What private IP addresses will be translated into what public IP addresses? So one for what private, one object is required for one for what private, and one object is required for what public, right? Means pre-translation and post-translation. Okay, now let me create two objects here, guys, on this ASA firewall. To create object, simply I'm going to run command object network and then name of the object. Name of object is, let's say, public, and here I'm going to define the range. So range is 1 dot 1 dot 1 dot 2 to 1 dot 1 dot 1 dot 3. This is my range. So I have created one object. So run object network. So you can see I have one object, right, where I'm defining this range. Now I'm going to create one object for my private network. So say object network and say private over here, private, or let's say VLAN 10, because we have lots of subnets in my private network. So say VLAN 10, right? Here I am going to define what subnet. Subnet, which subnet? 10.10.1.0. Subnet mask, and then subnet mask 255.255.255.0. Now guys, so run object. So here I have two object. This is post NAT object, means it is going to translate private IP address into these public IP address, right? Means after the translation, source is going to be from this subnet. So this is my post NAT translate object, and this is my pre NAT object, right? Means my private IP addresses, what private IP addresses are going to be translated from this subnet, all private IP addresses from this subnet. So this is pre NAT object. So I have created two object, guys. One is post NAT object, one is pre NAT object. Done. Now I am going to configure NAT. So as I told you, I have two way to implement any type of NAT, either manual and auto. So first I am going to use auto. So auto NAT means configuring NAT under the object, because it is object based NAT. It is object based NAT. So I am going to configure NAT under the object. Now question is, I have two objects. Under which object I will configure the NAT? Right? You have two objects. Under which object you are going to configure the NAT? So you will configure the NAT under that object which are going to be translated, means pre-NAT object. So which one is pre-NAT object, guys? Pre-NAT object is this one. So I will configure NAT under this object, right? So you will always configure NAT, means auto NAT, under that object which are going to be translated. Done. Now next thing. So let me go to object network and VLAN 10, which is my pre-NAT object, and here I am going to say NAT. Now interface. So understand the traffic flow. First, your traffic will hit on inside interface. First traffic hit on inside interface, then it goes to outside interface. So while moving from inside to outside, ASA need to translate. So let me say traffic who is coming from inside and going to outside, right? Do the translation. do the translation for traffic coming on inside going outside. Okay, if you want to configure NAT for the traffic coming from outside to the inside, then your command is going to be NAT outside inside, like that. Fine. Now guys, NAT inside outside, after that use keyword dynamic. I'm using configuring dynamic NAT, so dynamic. And after that, see, I am already under the pre-NAT object, right? So here I don't need to define pre-NAT object. I'm already under pre-NAT object. So let me tell about the post-NAT object. So what is the name of post-NAT object? Public. So let me say public here. Here you can see post-NAT object is public. Public, okay? So public. So hope command is clear. NAT inside, outside, dynamic, and then object. Which object? Post NAT object, where public IP addresses are there, means range of public IP addresses are there. Okay, so this is the command guys to configure NAT. Now exit. Okay, so run NAT. So you can see your NAT is under object. Under which object? VLAN 10. So you can check. So NAT, you can see this NAT is attached in section 2. In section 2, this is auto NAT section 2, right? So implementing auto NAT attached with section 2, manual NAT attached with section 1. When I will configure the manual NAT, you will see rules will goes under section 1 automatically, and we have 0 hits, right? 0 on translated hit. Okay, hope this is clear. So this is how we can configure guys dynamic NAT. And here you can check the object as well. So object, so run object, you can see here. Here we are not able to see the NAT configuration under this object, under pre-NAT object, right? NAT configuration is not showing over here. To check the NAT, you can run command so run NAT. So run NAT. Okay, so you can see NAT is under your object, and so NAT. Fine. So NAT pool, you can use this command. You can see the pool. In the pool guys, there are 2 IP addresses. How many IP addresses are allocated? 0, right? So both IP addresses are free now. Now I am going to access PC1, means which is in VLAN 10, and let me try to access internet. Let me see PC means VLAN 10 users are able to access internet or not. So let me access the PC guys, and let me say IP address DHCP here, IP DHCP, so that this PC can get IP address. Okay, you can see this PC got the IP address 10.10.1.1, and let me ping 8.8.8.8. Ping is not working. I think there is some problem on core switch. Just wait guys, let me correct the configuration. The previous configuration, I was using same lab in previous video as well. So IP route, so yes, you can see default route is incorrect here. Let me correct it. Say do so run section IP route, and let me remove this default route configuration here. And now I am going to tell to ASA Firewall to advertise one default route to core router, right? Because core router don't have any default route. Do so IP route. We don't have any default route here. So when PC1 will ping to 8.8.8, core router is going to drop the packet because core router don't have root. So let me take you to ASA Firewall, and here I'm going to say router OSPF 1. As we are running OSPF protocol here, I can run this command. Default information originate always originate albis. Now it is going to advertise one default route to core router to core switch, and now do so route. You can see now we have one default route through OSPF protocol. Now again let me take you to PC1, and this time I am expecting that PC can ping to 8.8.8, and you can see ping is working. Ping is working, guys. That means VLAN 10 users are able to access internet. And NAT rules are in which section, guys? In section 2. Is there any rule in section 1? No. Right? But suppose if same rule is matching in section 1, then guys, VLAN 10 users can never ping to internet. Never ping to internet. Why? Because first it is going to check what section 1. So you can see there is correct NAT configuration on ASA Firewall. But what I will do, if I will configure one manual NAT over here, and that NAT is matching same subnet, then what will happen? That manual NAT will attach with section 1, then VLAN 10 users cannot communicate. Let me do one thing. Let me create one. So object is already there. I'm going to say NAT inside or outside, inside, outside. See, I'm configuring manual NAT this time. That's why NAT configuration is in global mode. I'm doing the configuration in global mode, right? NAT inside, outside, and then I can say the pre-NAT object. Pre-NAT object is private, where we are matching 10.10.1.0/24 subnet, right? Here dynamic keyword, source dynamic, and then private. This is private is the name of my object, which is matching same subnet. And then guys, I'm going to say translate this source to the object any, let's say ABC, and I am going to create ABC object. First I need to create ABC object network, let's say ABC, and here I am going to define one range, incorrect range, let's say 2.2.2.1, which is another, let's say internet, 2.2.2.2. Done. And now I am going to configure this NAT here. See what happened. Private does not match an existing object or object group. So where's the private? So object, so run object, here, so run object under object. Okay, we don't have any object with name private. I was thinking the name is private, but name is VLAN 10. Sorry, let me correct it. Name of my object is, means pre-NAT object is VLAN 10. So let me say VLAN 10 here. Done. So I have configured the NAT, guys, and now if you will check the NAT, so NAT, you can see we have now two sections, section 1 and section 2. Section 1 manual NAT, right? Manual NAT is section 1, section 2 auto NAT. So now ASA Firewall will check section 1 first, then section 2. In section 2 we have correct NAT configuration, but still you can see PC1 can now not ping to internet. You can see ping is not working. So this is why I am telling you again and again, you should plan it very carefully. NAT rule should be planned very well. If rule is conflict, is matching with guys other rule in the upper section or at the upper position, then your NAT rule will not work. It is not going to, ASA is not going to check that rule, right? So now ASA Firewall is translating same source in different public IP address, because Same subnet is matching over here. Source is this NAT guys, means my SIM private IP address, and destination is post NAT object is ABC, where I'm matching different subnet, right? So I'm going to remove it, manual NAT, but this is manual NAT configuration, right? And manual NAT is section 1. Okay, so to remove manual NAT, what we can do, go to config T, and under global config mode I have to remove this command, no, and I'm going to say no object ABC. I have delete the object as well, no object network ABC, right? Now you can see so run NAT, okay, and so run object. Now again you can see PC1 can ping to 8.8.8. You can see again ping is working, right? And now guys, on ASA firewall, if you will check, so NAT and let's say pool, so you can see allocated IP address is 1, right? This is the range, and one IP address is in already use, right? So one more user can ping 8.8.8. So what I am going to do, let me take you to core switch, and from core switch also I'm going to ping internet, or I'm going to create one telnet session, telnet 8.8.8.8. It should work. Why it is not working? Let me do one thing. From the VLAN 10 interface I have to telnet it from the same subnet, because now source will be 10.1.1.2. The IP address which is running on E0/0, which is connected with ASA firewall. This is why I am not able to telnet internet router. So control C. Okay, now I am going to say telnet 8.8.8.8 and source VLAN 10 interface. Okay, password is required, but password is not set on the internet router. This is why this device is not, means core, from the core layer switch I am not able to telnet internet router. So what I am going to do, I am going to configure one password on line VTY interface on the internet router, just for the verification guys. Line VTY 024, and say what, no login, let's say. Now it will not ask for password. Now again let me take you to core switch, and let me say telnet 8.8.8, and you can see I have now access of internet router guys. And here if I will run command who, so it will show me my public IP address, not my private IP address. Getting my point? So you can see IP address. Who have telnet access of this router? 1.1.1.2, the public IP address. And IP address of this switch is guys different. 10.10.1.254 means last IP address of subnet for VLAN 10, right? So on the ASA you can see in the pool guys, you have two public IP address, and both are now allocated. Both are now allocated. So is there any free public IP address available in the pool? No. So can PC2 ping to the internet? Let me try. IP DHCP. Yes, this PC have IP ping 8.8.8.8. Is ping working? No. Why ping is not working? Limitation of dynamic NAT. We have only two public IP address in the range, in the pool, and already two users are using internet, right? So you can see ping is not working. On ASA firewall you can see both are allocated. But from the core switch guys, if I will terminate the telnet session, from the core switch, let me say exit. I've exit the telnet session. Now why PC2 is not able to ping? So go to ASA Firewall, and both it's showing both are allocated, and even PC2 is not able to ping. So this is simulation. Here I need to clear accelerate. So I have cleared the translation table, and now you can see PC2 is able to ping. Now PC2 is able to ping, but can PC3 or any other device ping to internet? No, because again both public IP addresses are allocated. Okay, so this is guys disadvantage of dynamic NAT, and this is why we are not using it. This is why we are not using it. Now I'm going to configure same thing through manual NAT. By the way, I have already shown you the manual NAT configuration, but again, if you want to see the manual NAT configuration guys for the same task for the dynamic NAT, let me tell you. So run NAT. So NAT is here in section 2 guys. So run NAT. This is my NAT configuration. I am going to remove it, and you can see NAT configuration is under object. Under which object? Under object VLAN 10. So I am going to say object VLAN 10 and network here, and say no to this NAT. I have removed the NAT configuration. So run NAT. Now you can see we don't have NAT configuration. So NAT, nothing is there. So object, we have some. So network of so run object. So yes, we have 2 object. Now if you want to configure manually, right, means dynamic NAT by using manual method, then you have to configure NAT globally. So here you will say NAT, and then inside outside, inside outside, then source dynamic, and then define pre-NAT object, and after that post-NAT object. So pre-NAT object is VLAN 10 and post-NAT object is public. Done. So run NAT. So this is my NAT configuration. Now you can see NAT configuration is under global configuration mode, right? Not under object. And so NAT, you can see section 1. NAT rule is attached in section 1 automatically because this is manual NAT. And again PC1 can ping to internet. So NAT pool allocation 0. Ping 8.8.8. What happened? Is there anything wrong guys? So PC1 PC2, why ping is not working? Let me troubleshoot it. So let me debug the NAT, debug IP, sorry, debug NAT only, and now let me ping. Yes, it is performing translation. What it's saying, let me check. Allocate dynamic accelerate inside out, clear accelerate. Now you can see. So this is in virtual guys, you have to run clear accelerate again and again. but you can see ping is working. PC1 is able to ping. Then PC2 can also ping. You can see PC2 is also working. If I will put if I will send I continuously ICMP traffic from both PC, from PC1 and PC2, then you will see you don't have any free IP address. So NAT pool, both are allocated. Now third user cannot access internet. Okay, so this is dynamic NAT configuration by using manual method. Okay, now guys, next thing, let me stop the ping here. Also let me stop the ping. Now guys, as we have some problem over here in dynamic NAT, means only two users are able to access internet at a time. This is the problem. That's why now I am going to configure dynamic PAT here. Okay, so first of all, let me remove the dynamic NAT configuration. Say so run NAT, and I am going to remove this configuration. No. And guys, as you know, dynamic PAT is many to one translation, means many private IP addresses gets translated into single IP addresses, right? IP address. So here I need to again create one object where I am going to define a single IP address. Okay, so let me do one thing, say object network, and then name is, let's say, PAT public, PAT public, or it will be better if I will say public IP for PAT, or public IP PAT. Let's say this is the name, and here I am going to say host 1.1.1. Let's say 5, right? I want to translate all private IP address into this public IP address, right? And again, first I am going to use auto method to configure it. So auto method means I will configure NAT under the object. Under which object? Under pre-NAT object. Okay, and which one is pre-NAT object, guys? So run object, this one, VLAN 10, right? This is my pre-NAT object. So go to object network VLAN 10 and say NAT inside, outside, inside, outside. After that dynamic, then pool, post NAT pool. Post NAT pool is public underscore PAT. So let me copy the name and let me paste it over here, and let's hit enter. Now so run NAT. You can see NAT is under object, that means it is a auto NAT, and if it is a auto NAT, then it will goes to section 2. So NAT, yes, you can see this rule is under section 2, auto NAT policy section 2, right? And so NAT pool, this time we don't have any pool. Okay guys, so I have configured the PAT here. Now let me check PC1 is able to ping. Yes, PC1 is able to ping. And do you want to see the public IP address? Debug NAT 255. It is translating into this IP address 1.1.5. Even when PC2 will ping, PC2 will also get translated into same public IP address, right? 1.1.5. Both are getting 1.1.5. Okay, so this is what dynamic PAT configuration on ASA firewall. Hope this is clear to you now. After the dynamic pattern, again guys, you have one more option to implement dynamic pat, that is manually. So to configure manually, what you can do, first of all, so run NAT. First of all, I have to remove this NAT configuration from this object network VLAN 10. I'm going to remove this NAT configuration from here. Done. And I will configure NAT globally. NAT inside, outside, source, dynamic, and then your pre-NAT object is VLAN 10, post-NAT object is public NAT, public underscore NAT. So what's it does not match, I think public pat object name is what guys, so run object, yes it's public pat. So NAT source dynamic VLAN 10 public, it's pat not NAT, pat. PAT pat like this. Okay, and so run NAT. So this time I have configured NAT globally, that means it is manual NAT, so it will goes to section 1. So NAT, yes you can see it is in section 1, and again PC can communicate. Clear accelerate, go to PC1 and ping to 8.8.8. See, ping is working. This time all the devices will get translated into single public IP address. You can see, keep pinging to 8.8.8 from PC1 guys. Again now I'm going to start ping from PC number 2 also. See, both devices pinging, right? And now I am going to take telnet access from core switch. Telnet 8.8.8.8 and source VLAN 10. See, I have even telnet access, right? With 10.1.1.1, I will have access with 10.1.1.1. See, sorry, 1.1.1.5. 1.1.1.5. Okay, because this IP address is in the object. I've defined this IP address under the object. So run object. So you can see this object. Fine. Hope this is also clear guys. So we seen the dynamic NAT configuration, dynamic PAT configuration by using both method, right? And guys, even you know, if I want to configure this ASA firewall in such a way so that when dynamic, it will look up for dynamic NAT first. Dynamic NAT. If range is full, then it should perform PAT. First look up for dynamic NAT. If there is no space, no public IP address is available, then use PAT for the translation. Yes, we can do that also. Okay. So first it will, as you know, the order of NAT. First it is going to check what section 1. So in section 1, you can put the rule. You have configured the NAT here, and this NAT is so run so NAT. This is in section 1 guys, PAT. So I will put one command here. That command can be this one, this command, and here I can add one keyword, that is interface, right? like this. Like this, we can configure firewall in such a way so that first it will look up for dynamic NAT. If a space is available, if public IP address is available, then it will perform dynamic NAT. If public IP address is not available, then it will perform PAT. Okay. Okay. So if the public pool full, then use the ASA outside interface. Move to dynamic PAT. Okay, now guys, I think video length is getting lengthy, so what I will do, I will divide this video into two parts. Let's say this is part 1, and in next part I will discuss rest type of NAT on ASA firewall. That means the implementation lab only. Okay, because here I have some servers as well, so I need to configure bidirectional NAT also. So I will do those configuration in next video. Okay, hope this video was helpful for you. If you have any question guys, any query, please let me know in the comment section. If you have learned something from this video, anything, just type yes in the comment section guys, and please hit on like button. Once you will type yes in the comment section, I will get to know yes, this video is helpful for you and you want more videos like this. Then only I can make part 2 of this video, right? Because your comment, your likes really motivate me to make more videos. Okay, so if you have learned anything guys, just type yes in the comment section, and please hit on like button. Please motivate me to make more videos. Okay, now this is all about today guys, all for today. We'll meet tomorrow in next video, or maybe after tomorrow in next video, where we will be discussing the next type of NAT configuration on ASA firewall. Thank you, thanks for watching. We'll meet soon in next video.